Hello and welcome to today's lesson on the particle model. Today we will learn that matter is made up of tiny particles, either atoms or molecules, that are constantly moving. We will then move on to looking at spaces and attraction between particles, learning that particles have spaces between them and attract each other, with varying strength depending on the type of matter. Finally, we will explore how particles are always in motion and how their speed increases with temperature. Let's get started. All matter, whether solid, liquid, or gas, is made up of tiny particles known as atoms. Atoms can either exist on their own or together as molecules. These particles are the fundamental building blocks of everything around us. Even though they are incredibly small and cannot be seen with the naked eye, they are constantly moving. For example, suddenly when you look at a glass of water, you see a liquid. In reality, this liquid is composed of countless water molecules, H2O, that are moving continuously. Particles in matter are not packed tightly. There are spaces between them. The amount of space varies depending on the state of the matter, solid, liquid, or gas. We'll look at these in detail one by one. In solids, the particles are closely packed together in a fixed and regular pattern. This tight, orderly arrangement exists because the particles have strong intermolecular forces holding them together. The particles do not move freely. Instead, they vibrate about their fixed positions. Although they move, they don't change locations, which is why a solid maintains its shape. As the particles are so closely packed, the distance between them doesn't change, making them incompressible. For these reasons, solids have a fixed volume and shape. In liquids, the particles are also close together, but not in a fixed arrangement. The particles in a liquid have more freedom to move compared to those in a solid, as they can slide past each other. Accordingly, liquids have a fixed volume, but do not have a fixed shape. They conform to the shape of their container. Unlike gases, liquids are not easily compressed due to the relatively close packing of their particles. In gases, the particles are far apart and are not arranged in any pattern. They have weak intermolecular forces, allowing them to spread out quickly to fill the volume of their container. Gases do not have a fixed volume or shape. They can expand to fill any space available to them, which makes them easily compressible. The particles in a gas move rapidly and randomly in all directions. They frequently collide with each other and the walls of their container, which accounts for the pressure exerted by gases. One key aspect of the particle model is that particles are always in motion. The speed at which these particles move depends on the temperature. When the temperature increases, particles gain more energy and move faster. Conversely, when the temperature decreases, particles lose energy and slow down. We will develop this idea when we come to discuss changes of states in matter. This understanding of the particle model provides a foundational perspective on how matter behaves on a microscopic level, helping us make sense of various physical properties and processes in everyday life. Today, we explored the particle model of matter. We discovered that everything is made of tiny particles, either atoms or molecules, that are always moving. We learned particles are spaced differently in solids, liquids, and gases with varying degrees of attraction between them. Finally, we discovered that particle speed changes with temperature, affecting how matter behaves. Understanding these concepts helps us explain why materials have different properties and how they change state. Next, we'll develop this knowledge by exploring density.